We are discussing a differential equation, a non-homogeneous linear differential equation by using method of variation of parameters. First we have to express in a standard form function of d into y is equal to phi of x, d square by dx square is equal to capital D square, because to express in a standard form we need to substitute d square by dx square is equal to capital D square and d by dx is equal to capital D. Then the above equation becomes d square y minus 2dy plus y is equal to e raised to x by x. So take y common in the right side, d square minus 2d plus 1 into y is equal to e raised to x by x. So now it is in standard form. Once it is in standard form, we are writing the auxiliary equation by replacing d by m square minus 2m plus 1. You neglect y and right side, you will get a auxiliary equation. Auxiliary equation is a quadratic equation, isn't it? So it is a imperfect square, like a minus b whole square form. A square plus b square minus 2ab, or otherwise you can use factorization method also. What is factorization method? 1 into 1 is 1, again 1 ones are 1, both are minus means you will get minus term. M square minus m minus m plus 1 equal to 0, m into m minus 1 minus 1 into m minus 1 equal to 0, m minus 1 into m minus 1 equal to 0. Once you get m minus 1 into m minus 1 equal to 0, you will get roots are 1 and 1. Now based on the roots, we are writing the complementary function. What is complementary function? With respect to the equal roots, c1 plus c2x into e raised to 1x. With respect to two equal roots, c1 plus c2x into e raised to 1x. Next we are multiplying e raised to x into first equation, first term as well as second term. You will get c2x e raised to x. Once you get this equation, we are going to replace c1 by capital A, c2 by capital B. c1 by capital A and c2 by capital B are called functions of x. Now I have replaced A and B here. Once you replace A and B, you compare this equation with the standard. Here y1 and y2 are called independent solutions. We are going to equate, or we are going to compare these two equations to get the value of y1 and y2. The coefficient of A is e raised to x. Here coefficient of A is y1, therefore y1 is equal to e raised to x. Here you will get x e raised to x. Once you have y1 and y2, we are finding y1 dash and y2 dash. E raised to x, apply UV rule, first function into e raised to x, differentiation is e raised to x, plus second function e raised to x into differentiation of x is 1. Next we are finding the Wronskian. What is Wronskian of function of y1 and y2? y1 into y2 dash minus y2 into y1 dash. Just substitute e raised to x into y1 dash is x e raised to x plus e raised to x minus y2 is x e raised to x into y1 dash is e raised to x. Just multiply it. E raised to x into e raised to x. When bases are same, powers are added. X plus x is 2x. So x e raised to 2x plus e raised to x into e raised to x is e raised to 2x minus x e raised to again 2x minus x e raised to 2x plus x e raised to 2x get cancelled. You will get w is e raised to 2x, and what is phi of x is e raised to x by x. Once you know all these things, we have capital A and capital B value. Capital A value is minus integration of y2 into phi of x by w into dx plus k1. B value is integration of y1 into phi of x by w into dx plus k2. Just substitute the value of y2. What is the value of y2? X e raised to x into what is phi of x value? E raised to x by x divided by what is w value? E raised to 2x into dx plus k1. Similarly, y1 is e raised to x, phi of x is e raised to x by x into dx divided by w value is e raised to 2x. So x and x get cancelled, again e raised to x into e raised to x is e raised to 2x divided by e raised to 2x, e raised to 2x, e raised to 2x get cancelled, you will get 1, integration of 1 is minus x plus whatever the constant. Similarly, e raised to x into e raised to x is e raised to 2x divided by e raised to 2x into 1 by x into dx, e raised to 2x, e raised to 2x get cancelled, integration of 1 by x is log x plus k2. Once you get the value of capital A and capital B, you need to substitute back into equation number 1, where you have changed c1 and c2 into functions of x. Substitute it, that is a value is minus x plus k1 into e raised to x plus b value is log x plus k2 into x e raised to x. So multiply, first you have to have constant, like you have to have complementary function first. So for that purpose, k1 into e raised to x is k1 e raised to x plus k2 into x e raised to x is k1 x e raised to x. Then minus x into e raised to x is minus x e raised to x. Finally, log x into x e raised to x is x e raised to x into log x. If you have any doubt, you can feel free to ask. Anybody? Thank you. Please write next example.